Well, in the previous videos, we learned about composition of functions. In our last video for this section, we're going to do decomposition of functions. We're kind of going to do it in the reverse order. So, if we're given this function, h of x equals radical x squared plus 5, and we are asked to write this as the composition of two functions. Well, we need a function, since we're going to use only two functions. One of them has to take the square root of something, and the other one would have to be something like x squared plus 5. So I will use the letters, say, f of x equals x squared plus 5. So that takes care of under the radical. And then I'll say maybe g of x equals radical x. That's really all we need to do. Well, almost. We haven't expressed the composition yet, but I know now, because I've taken care of the x squared plus 5, and I've taken care of the square root of x, the square root function. Now I need to know what order do I do it. So h of x, this function here, if I were to say that x is equal to 0, and I said compute the value of h of 0, if you plugged it into your calculator, the first thing you would do is not a square root. The first thing you would do is take 0 squared plus 5. So which function is that? F, x squared plus 5. F of x. Notice I'm giving some room here. That's the first thing you do, so that's the inside equation. And the other one is going to be the outside. And that's it. We created ourselves two functions, g and h, in a way such that h of x is equal to g of f of x. And you can easily test this, and also you could write it like this, g composed with f of x. But I prefer this form. So that's equal to g of, and what is f of x? X, let me do it this way. We're plugging f of x into g. So f of x, if we plug it into g, we're just going to get this, which is equal to x squared plus 5. Okay, so we verified that it works correctly. Now suppose we want to do the same thing, but with the composition of three functions. Okay, so I need to come up with three functions now. It's very simple. Notice what we have to do. We have to have a function that squares something. We have to have a function that adds 5 to something. And we have to have a function that square roots something. Okay, so one of these functions is going to be the same down here. Let me see, what letters can I use? F, G, H. Can I reuse F and G? G. Sure, I'm going to reuse F and G. So actually, let me use the g of x, radical x. So that one can stay the same. Because now I need something that squares something and something that adds 5 to something. So I'll use k of x, squares it, is x squared. And j of x adds 5 to something. So don't say x squared plus 5, just say x plus 5. So now I have a function, I'll go backwards, that, actually I'll start in the middle. I have a function that squares something, so if I plug in x, it'll get x squared. It'll become x squared. I have a function that adds 5 to something, so if I plugged in x squared here, I would get x squared plus 5. And then I have a function that whatever you plug in, it'll put a radical over it. So, once again, let's see, the composition of three functions. H of x is the same as, well, if I gave you a number, say 2, and said compute h of 2, what's the first thing you would do if you plugged it into the calculator? Not the square root, not the plus 5, you would take the 2 and square it. So the first thing you're going to do is k of x. And again, That's the x squared function. Give yourself some room here. That's the first thing. So this is the innermost function. What would the next thing be if you plugged in the 2 squared? If I said x was 2 squared, then you would add 5. So the next thing you need to do is add 5 to this function, which just means apply the function j to k of x. So now we have x squared plus 5 in this composition. The last thing we need to do is hit the square root button, the third thing, and that means put g like that. I'll let you verify this, but k of x is, k of x is just x squared. So if you plug x squared into j, it's going to become x squared plus 5. So that adds the 5. And then if you take x squared plus 5, which is this that I'm underlining, into g of x, you plug it in here, that means it gets put under the radical. And it works. All right, one more. The function is j. It's different from the j I made up in the previous problem. J of x is the absolute value of 2x minus 5 as the composition of 3 functions. So hopefully after doing the previous example, you can tell me what the 3 functions are that we would need. And I think I'm going to go ahead and use f of x, what else? G of x, and maybe k of x. I'm reusing the letters, but we're done with the previous problem. So, what do these functions have to do? I need 3 functions. One of them has to do what? Has to multiply something by 2. So f of x equals 2x. It doubles it. I need a function that subtracts 5 from something. Okay, subtracts 5. So g of x equals x minus 5. And lastly, I need something that takes the absolute value of something, of the input. So k of x is equal to the absolute value of x. All right, so we've got our 3 functions. So now, let's make sure we get them in the correct order. They have to be in the correct order. Once again, if I said plug in the number 6 for x, j of 6, in the calculator, what's the first thing you would do? 2 times 6. So the 2x function is the first thing you'd have to do. You're multiplying something by 2. So leave some space. That would be f of x. So that's the equivalent of 2x. Now we need to do the minus 5 function. I need to subtract 5. So I'm going to say g of f of x. And what that gives us so far, g of f of x, means you're plugging f of x into g, so it would be a 2x minus 5. So now we have everything except the absolute values. And then we apply k. And that's it. So once again, f of x was 2x. So g of 2x. G of 2x would be 2x minus 5. Okay, that's the inside there. And then if we plug 2x minus 5 into the function k, all k does is put absolute values around whatever you've got going, whatever you're inputting. Okay, yep, these take a little bit of time to get used to. Now, the second half of this example and we'll be done. Do the same. So with 3 functions, I want to represent this function. Now, notice what's going to happen. This is absolutely different than this one. The result, for the most part, the results would be absolutely different. The minus 5 is inside the absolute values here. The minus 5 is outside the absolute values in this one. But look at this. We can use the same 3 functions. I need a function that multiplies, that doubles a number. That's f. I need a function that takes the absolute value of something. That's k. I need a function that subtracts 5 from something. That's G. We just have to put these in a different order. That's all there is. So again, now let's take the number 3. If I said, what's f of 3? Plug it into your calculator. What's the first thing you would do? 2 times 3. So the 2x function is the first one. So f of x equals, which one, the 2x? That's, oh, rats. Let me change the name of this f. I didn't realize I was going to need this f. So just for that, it doesn't make any difference. Let's call this one L. Script L, L of x. That name doesn't make any difference. L of x is equal to f of x. F of x is 2x. All right, after you computed 2 times x, what's the next operation you would do? Subtract 5? No, you would do the absolute value. So the absolute value is the k of x. So we'll take k of f of x. And then the last thing we do, the minus 5, will be the outermost function. The minus 5 is g. So we did the same, and we used the same 3 functions from the previous example. And our new L of x is this. And let's just kind of talk through it real quick. F of x is 2x. So 2x is getting plugged into k. K of 2x would be the absolute value of 2x. And then we're plugging the absolute value of 2x into g. And we're replacing this x with the absolute value of 2x to get absolute value of 2x minus 5. So indeed it works. So you'll be able to practice this on some of your homework problems. And after you do a couple, I think you'll find that it's not too difficult.